So, thank you very much for coming here. Here is the reactor heat exchangers project group. We will give you some updates about all activities we did in this year. Here is Juan Carlos. I'm working for Rittal, and Jabari is working from GM Gross Engineering. So why we are working in this group? So we have some targets. So the first one is provide documentation about and information about the reactor. Also, to give you the different solutions for deployments, as well harmonize with partners and other project groups the documentation. Obviously, it's important to have some harmonization between groups. The height of the heat exchanger is very important to fit the reactor. So such things are very important, and we consider as well these points. But also a very important point is to reduce the barrier of the implementation of liquid cooling. This is a new technology we have to consider. So many people ask about liquid cooling, but this is a new technology, and we have to do everything easier to implement this. Which activities we are doing there? For example, we work in to show the community the conditions in which the reactor are working, which parameter, temperature, pressure, delta T's, approach temperatures. I think this is very important to show which is possible and which is not possible to implement the liquid cooling. But also to give some info about the performance of reactors, liquid cooling. There are three different solutions, so traditional reactors and another one. We will come later to this point. For these solutions, we need to know how works the reactor under which parameters are working better. The reactor are working in different scenarios. For example, for data center working with liquid in the raw, and data center which have not liquid in the raw, so air-cooled data centers. For these topologies of data center, there are a solution. We worked this year in a white paper. We try to give more info about what is possible to do, what is the performance of two different reactors. One was of the self reactor, and we based in this reactor we improve a new one reactor. This is the customized, and this improvement was very high, so it is possible to increase a lot the power of the reactor. It is possible also to reduce the approach temperature, only increasing a little bit the size of the reactor. And in this white paper, you will be able to show these parameters in which we calculate the reactor and under which circumstances is able to improve the performance of the reactor. Yeah. Like I said, increase the power, the performance of the rack is possible, increasing the performance of the reactor, and we are able to do that for these three scenarios, for the traditional reactor, for the air-assisted unit, and the hybrid solution. As well, we can not also increase the power of the rear door. It is also possible to reduce the approach temperature in case you want to increase the temperature of the facility water. So.
Okay, so that was a recap of what would have been accomplished this year in terms of publishing that white paper. In terms of our current efforts, we have a lot of very interesting projects, and I'll just remind you, each of these that I'll talk about, we have more in-depth presentations following this one, so I encourage you all to go and check those out. So the first was the densifying modular data centers, and this is a partnership between the modular data center sub-project under DCF and the radar heat exchanger project. And what we're looking at really is to boost or expand the performance of the modular data center up to or above 500 kilowatts. We're looking at everything, the rack configuration, white space, the infrastructure layout, as you see in this image here that we have extracted from that paper. And we're also looking at the climate, location and climate, and how that would affect the efficiency of this operation, as well as the potential for heat reuse. So we're getting help with that from David G, with that specific aspect, and Carl Robb is coming in from the modular data center side of things, and John Fernandez is helping from the radar heat exchanger side under Meta. And why are we doing this, right? So we want to combine the versatility of the modular data center with the performance, the heat transfer performance of hybrid cooling, meaning combining a cold plate with a radar heat exchanger. And if you can get up to 500 kilowatts of performance out in wherever you want to put a modular data center that has applications for market in AI, in edge, HPC. So that is a solution for those that segment of the market. And with the versatility of the modular data center, you can now look at more options for heat reuse because of the form factor and where you can place it. Another work stream is the microchannels, or the aluminum microchannel heat exchangers, as used as door heat exchangers, and that's a partnership between Danfoss, Boyd, and Meta. So we have a presentation coming up with Sanka and Philippe. Sanka from Danfoss and Philippe from Boyd, where they're going to go through this. But that white paper is going to explore how we can apply aluminum microchannel heat exchangers to door heat exchangers or door heat exchanger technologies. And the intention really is to get an answer to that question: how can we compare, apples to apples, the performance of a traditional fin and tube copper heat exchanger with a microchannel, and how that can specifically apply to door heat exchangers. And why are we doing this, right? So those of us in heat transfer, or who have encountered heat transfer in other industries, is very popular. The aluminum microchannel in the automotive industry or in HVAC industry, you would encounter this, and they have been proven in terms of their performance. So we want to see if that can be applied as well to door heat exchangers. So we want to establish what those benefits could be and get some empirical data for that. We also want to, not enter this with rose-colored glasses. We understand that there are drawbacks to aluminum microchannels and, aluminum really. For instance, the water chemistry. We're going to go in and have those discussions up front so you can see how we would manage that, or we'll try to manage those issues in the white paper. We have another really interesting topic. This is being led by Meta. The concept is from Meta. It's being led by Jared Wyatt. It's an alternative to rack-mounted door heat exchangers, where we look at moving the door heat exchanger infrastructure over to the facility. And what are the drivers for that approach, right? You get a simplified design, a reduction in footprint for the data center, or at least for the aisles. So for instance, instead of, if you're moving racks with door heat exchangers, now you can design your facility to just cater for the racks and not for that extra weight and bulk. because you would have moved that over to the facility side of things. You don't get, if you do adopt this, or potentially, as we're thinking, you'll have no impact to the rack design itself and or the integration and shipping, right? You're going to do all of your innovation, etc., on the data center side. You could also reuse this for different generations of racks, right? So you don't have to change out your door heat exchanger every time from the facility. You can just use it as a part of the infrastructure and update your generations. And the good thing about this, the specific project, is that we have a prototype in the Experience Center, and Jared's been manning it for the past couple of days. So we encourage you to go out, get your hands on it, see that it's actually a real thing, and get your feedback on it, right? Feel free to give it to us, because we want that. If this is something that you think can apply to your facility, that is, or you think something you want to adopt potentially on a small scale, you can let us know. Talk to Jared, talk to John Fernandez or myself. We really want that feedback. Finally, the door heat exchanger requirements. It's still in Rev 1. There are some updates we need to make to that. We have references to old ASHRAE standards like A1 and stuff for the air, and now W1 and W2, etc. for the water. And now that's been updated to W70, etc. So we have to clear up some of those references to industry standards, as well as clear up references to updated OCP specs. So we're going to be going through that exercise. We also have to look at maybe doing a 3D model, because when we look at the new blind gate manifold design, there may be an issue if you have a blind gate manifold and a bulky CDU in terms of space available, etc., in the cabinet when you look at redundant hoses, etc. So we're going to have to kind of look at that and update the spec accordingly. The target for that is going to be Q1 2024.
Yeah, for future efforts, we did something last year. One project was how to deploy the same rear door and the same equipment for multiple generations in order to be more also to increase the sustainability, but also to reduce the cost. For sure, the CapEx is important for everyone, and it is possible for sure to use the same rear door, the same equipment, rack, the same platform for multiple generations of servers, IT equipment. This is currently on hold. There are another project. This was a reference of megawatt deployment for rear doors. It was in Europe, in Switzerland. I think it's important to give references to the community to be able to develop the new data centers, taking in account the old experiences. And it's done one part, but this is already also on hold. Last, therefore, we are now, after next week, I think, or next week, we will start with another project. It is how to connect the rear door with the rack. So there is mechanical issues, how to connect the rear door from the top, from the bottom, how to connect the rear door also if you are opening the rear door from the left, from the right. In which part is the hot manifold, the warm manifold, and how to connect it with the rear door. These points are very important for the community to be able to do standard racks or standard systems which are able to work in the same way for everyone. It is almost very difficult to change the cold and one manifold for the server manufacturers, and it is very important to have all the manufacturers work in the same direction. But also the termination, the couplings from the rack to the rear door, how to solve this problem. Power. we are speaking about 48 volts DC busbar. It is also nice to have 48 volts for the rear door as well. So if we have this power there, how to connect the rear door with the DC busbar. So every 2 weeks we are there. If you have interest, if you can, you are able to support this group, please come to us. The calls are nice people there. You support us if you are infrastructure. Provider of rear doors. Also, if you are a customer, you deploy rear doors in your facility, please come to us. Maybe we can develop new products better. We will consider everything, every input you can give. Here you can, you have the QR code to the mailing list as well, and yeah, we're happy to have you there. Thank you very much.